So next is the cost benefit analysis of the energy efficiency opportunities. So under this, we can say that there is a cost benefit analysis being followed, which may be the study of the payback period or life cycle cost analysis, that what if the project is there, so whether it is feasible or not, we should go for that project or not, and if at all we are going for that project, at what rate we will be getting the benefits, or at what rate first of all we will be recovering the money which we have invested on it. So in short, we can say that all the cost, owning, operating, maintaining and disposing of the projects are taken into account, and you can say that this is nothing but the financial analysis of the project. Okay, or you can say the economic aspects are being taken care of using this. So first is the life cycle cost analysis. So it is an economic method for the project financial evaluation. It relates with the owning, operating, maintaining and the disposing of the projects. All these things are taken into account. So it is abbreviated as LCCA. So here the how it is different from the simple payback period, because simple payback period which mainly focus on how quickly our initial investment can be recovered, but the life cycle cost also take care of the cost which are reoccurring due to the operation and maintenance, etc., which is taken into care. Okay, so it is the in-depth analysis of the project. So how do we uh, analyze these financial components? So first is the LCC method, or the life cycle cost method. So another factor which is to be taken care of while studying the feasibility reports of these projects is that uh, many of the projects, or the maximum of the projects you can say, are uh, not invested at one go. In most of the times, loans are taken from the banks or other financial institutions, so that rate is to be taken into consideration. Okay, then if we are talking of the loan, then the time period also comes into the picture. Loan period is one, rate of interest is one thing, second thing, third thing can be the discount rate, if some discount is given. Okay, next it also helps, this life cycle cost analysis also helps in reaching the present value of the project. For example, if the project is started say 5 years back, some initial investment is done, then some discount rate is given to us, so what is its present value? Okay, so that is that can be evaluated. Some of the projects are on the flat same interest rate year after year, but few interest can be compounded or linked to the inflation. Okay, so or you can say the price escalations are also there, because of the purchasing power of the person also goes changing. If a person is having 1 lakh rupees at some year, at some point of time, then after 5 years or after 10 years, that 1 lakh purchasing capacity purchasing capacity of that 1 lakh will be reduced. Okay, so price escalation, inflation, all these things are also taken care of to estimate the project cost as the base rate. Okay, so another point or abbreviation which is of our interest is the MARR. In the private sector, the investor's discount rate is generally determined by the investor's minimum acceptable rate of return for the investments of equivalent risk and duration. Okay, so this is the minimum acceptable rate of return for the investments. This is MARR. Sometimes we ask for the full form of this MARR. We will do the numerical part of these financial aspects also in the assignment number 4. So there is nothing to worry about. At present, we are just going for the theoretical analysis. Next, we will also, in the coming lectures, most probably in the next week, we will also go for the numericals. So first is the SPV, or the single present value. So this formula is used to calculate the present value of a future cash amount occurring at the end of the year T. Okay. So future cash. Okay. For example, if the project is there and it is estimated that it is generating some X amount of future cash at the end of the T years, if some discount rate is given, then what is its present value? So this is formula is used to calculate this. So PV is equal to FT, future cash, into 1 upon 1 plus D to the power T, where T is the number of years. Next is the uniform present value. Okay, so it relates with the series of the equal cash amounts, okay, which are being pumped. Okay, so this formula is used to calculate the present value of the series of the cash equal amounts, okay, that reoccur annually over the period of n years. For the n years, if we are pumping some amount, fixed amount, same amount again and again annually, then for that project, if the present value is to be calculated, it is calculated using this PV is equal to a naught 1 plus d to the power n minus 1 upon d 1 plus d to the power n, where d is the discount rate and n is the number of years. So if the price escalation, if the that is to be taken into consideration, then the constant escalation rate, or you can say escalation rate, is the rate with which it is rising. So this formula is used to calculate the present value of the recurring annual amount that change from year to year at constant escalation rate. Okay, for example, you can say that escalation rate is 10%. Okay, so if a person is pumping so 1 lakh initially, then after 1 year it has to pump or indulge in 90,000 only. Okay, so this is based on this. So if the discount rate is given, escalation rate is given, and the initial a naught amount is given, then this present value of such products can be calculated. Okay, so and also, as I have just mentioned, that different countries have used different formulas for this to calculate the inflation aspect and also the discount rate. So if D is the real discount rate and capital D is the nominal discount rate and I is the inflation rate, then this real discount rate can be calculated using this formula. Okay, if any discount rate is affected by the normal discount or the nominal discount, and also taking into consideration the inflation, then discount real, which is applicable real discount rate, is calculated using this formula, and then it can be inserted as and where required. Similarly, the price escalation is the real price escalation and the normal price escalation, then the correction factor due to inflation is to be taken into account to get the real price escalation. Cash flow diagrams also helps in visualizing these things, that when and where, at which point of the time during the project the money was inserted in the project. So here again a formula of LCC or the life cycle cost is given. So this is the sum of, if there are n number of years, if the t if t is the year starting from 0, and if the project is running till n years, then life cycle cost can be calculated using this formula if the discount rate is known to us. So in short, we can say that, as I have just mentioned, that the life cycle cost is the total cost of owning, operating, maintaining, and also disposing of the technology during the lifetime of the project. So all these factors are to be taken into account for the calculation of life cycle cost. So uh, depending upon the situation, for example, if some of the total cost is given, discount rate is given, time is given, then we have to apply the above formula. If the future cash is given, then we have to apply different formula. If the individual components are given as mentioned here, so then we have to calculate using this formula of the life cycle cost. So if the this LCC is equal to I plus REPL minus RES plus E plus W plus OM and R. So what are these factors? This is the I is the present value of the investment cost, REPL is the replacement cost, RES is the residual value or the resale value, you can say, or the scrap value if we are going to dispose of that project. E is the present value of the energy cost, W is the water cost present value, and OMR is the operation, maintenance, and repair costs. Okay, so these are to be taken into consideration for the life cycle cost. So another two, three more these methods are given, and initial rate of return is abbreviated as IRR, net present value is the NPV, and savings to investment ratio is given by SIR. So while we have to calculate the net present value, it is calculated using NPV method. So this is the basic economic criteria which is used for the accepting or rejecting the project. Okay, for example, if we are going for any project study or beforehand, then whether we should go for that project or not, it is calculated using this net present value method. So here the mainly two considerations are there: cost and benefit, because it all comes under the cost benefit analysis. So if this subscript, for example, BT is the benefit in the year T, where CT is the cost in the year T, so and R is the rate, discount rate, and if it is running for n number of years, then this is calculated. So if we are putting these amounts in this formula, then we can beforehand calculate that whether we should go for this project or not. Because if our estimate is such that okay, after the, if we are going for this project for 10 years, then our benefit should be say 15 crore rupees. Okay, for example, mainly projects such as the toll toll plazas. So in that, initial cost is there, initial benefit may not be there, but if it is operating for n number of years, it gives the returns. Okay, so such type of projects are estimated beforehand. Next is the internal rate of the return. So this is again the feasibility of the projects. So here the same above formula is equated for zero value. So if we are uh, calculating the zero value, then we can get the discount rate. At what discount rate this project will give the zero value. So then this IRR, or the internal rate of return, may be adjusted to get the more benefit out of it. Okay. So same above parameters but equated to zero to calculate the IRR. And the simplest part is the simple payback period in which the initial cost is being discussed.